Welcome to EDU World Space.
Hello and welcome to this video solution of new merit. So here it's given that a 3 kg fish is attached to the lower end of a vertical spring that has got negligible mass, right? So the mass of the fish is given as 3 kgs, right? And it is attached to the lower end of a vertical spring having negligible mass and force constant K equal to 900 Newton per meter, right? The spring initially is neither stretched nor compressed. The fish is released from rest. Now you have to calculate the speed after it descends 0.05 meters from its initial position. We can take x to be equal to 0.05 meters, right? So now what you can do is you can conserve the energy to get the final speed of the fish, right? So what you have is, let's say here we have the spring and here we have the fish, right? Now this fish has descended a distance of x, right? And as a result, the spring is getting extended, right? Sort of like this it will be now, right? That means the potential energy that was initially present in the fish got converted to the spring potential energy plus the kinetic energy with which it is moving down, right? So that means you have got, if you conserve the energy E1, let's say this is point 0.1 and this is point 0.2, right? E1 will be equal to E2, right? Energies will remain the same. At E1, everything was stationary and the fish has got potential energy of mgx, right? Now E2 will be the spring potential energy due to elongation, plus there will be the kinetic energy of the fish, right? Half mv square. So we simply plug in those values. 3 times of g is 9.8 times x is 0.05, that is equal to half time k is 900 times of 0.05 squared plus half. The mass is 3 and v square. So from here you need to calculate v. So let's see how much we are getting. So the speed will be 0.48 meters per second, right? Next you have to calculate the maximum speed as it descends, right? Now what happens here is we need to calculate the equilibrium position, right? So to calculate the equilibrium position, we need to equate mg equal to k, let's say xm, right? Xm is the equilibrium position, right? Because at this equilibrium position, the forces will be balanced, right? So the mass is 3, g is 9.8, k is 900, xm, right? So xm you will be having equal to, which is 0.0327 meters, right? This is xm, right? Now what you need to do is you need to plug in this value in the same expression where you will have the maximum velocity, because at equilibrium position you will have the maximum velocity, right? So here I take it from this equation, or I can write it like mgxm now, right? That is equal to half k xm square plus half m v vm square, let's say, right? So this is 3 times of 9.8 times of 0.0327. This is equal to half times 900 times of 0.0327 squared plus half times of 3 times of Vm squared, right? So let's see how much we're getting as Vm. So the speed you will be having 0.56 or 0.57, you can take meters per second, right, as a maximum speed. I hope this is clear to you and have a very good rest of the day. Thank you.